Good day, everyone. Allow me to present to you the proposed queuing model for the processing of billing documents in the Department of Public Works and Highways, particularly in the Nagat Islands District Engineering Office. So let me read to you an overview of this queuing model or proposed queuing model. So one of the main priority objectives of the Department of Public Works and Highways in the Nagat Islands District Engineering Office is to achieve its goal, especially in terms of accomplishment billing disbursements. Currently, the said office has an existing released budget in the year 2022 of about 1 billion pesos and also has a remaining prior year's budget from the year 2021 and below of about 800 million pesos with an overall total of 1.8 billion pesos to be disbursed only until the end of the year in this case December 2022. In connection with the above information, the Department of Budget and Management has consistently released budget for every quarter of the year to any department with allocation already planned to be disbursed. In DIDEO, it has already been observed that at least 27 vouchers of project billings per month need to be processed completely to cope up with the monthly disbursement target already set in place. Because of this, for the purpose of convenience and fast disbursement, the department has created a team solely in charge on making and processing of vouchers until the billing is completely disbursed. The said team forms one group of people comprising of one person which is in charge of the printing of documents required and two assistant persons. So the real challenge here is that how can the department cope up with the target disbursement knowing that there are only 22 working calendar days in a month and with 27 vouchers that need to be urgently disbursed? How long should every voucher be accommodated and be processed until it is completely disbursed? So the next presentation or figure shows the data and variables we acquired from our previous uh, situation. So the number of server here is only one. Uh, we have a variable of letter M, so that implies or that represents the number of server, and the number of vouchers to be processed. The lambda variable is equal to 27 vouchers per 22 working days, or 1 point, if you are going to divide 27 divided by 22, so we will get 1.23 per day of vouchers to be processed. The service time here is assumed as 0.73 day per voucher or 17.52 hours or 2.19 working days. Now, if you wonder uh, why this 0.73 became 17.52 hours, it is assumed here that in one working day, there are 8 working hours. So it refers to the government time. So 0.73, uh, we just multiply 0.73 times 8 0.73 day times 8 working hours, so we get 1752 hours. And then we divide 17.52 hours with 8 working hours, so we get an equivalent of 2.19 working days as its service time. Then the average of number of vouchers in line, uh, the variable LQ represents this term. Then we also have this P sub O, which refers to the probability that no voucher is required for processing. And we also have this W sub A, which represents the average waiting time for a voucher not immediately served. We also have this P sub W, which implies the probability that a voucher will have to wait to be processed. And by the way, the model that we applied to this case is the multiple server exponential service time. So we go now to the solution for our model. So first, we compute the mu, which is equal to 1 over the service time. So we get 1.37 vouchers per day. Now to compute for the system utilization, uh, which is rho is equal to lambda over m times mu. So we get zero point 0.9 or 89.59% exactly. To compute for the percentage for the team service will for the team that to be idle or percentage is just we just deduct the system utilization to the number one. So 1 minus rho. So we get 0.10 or 10.409% exactly. Then from table 18.4, with having our m is equal to 1, and then our lambda over mu is equal to zero point 0.9. So we get the value for our LQ, or the average number of vouchers in line, which is 8.1 as shown in the screen. And we also get the probability that no vouchers required for processing. So that's P sub O is equal to 10%. The next is we calculate for the average waiting time for a voucher not immediately served. So we have this variable W sub A, which is equal to 1 over m times mu minus lambda. So to calculate this, we just have to substitute the values given in the previous slide. So W sub A, we get W sub A is equal to 7.01 days. Then lastly, we compute for the probability that a voucher will have to wait to be processed. But first, we compute first the W sub Q is equal to LQ over lambda. So WQ here we get zero point 0.3 day. After that, we can now compute for the P sub W, our probability that the voucher will have to wait to be processed. So that's equal to WQ over WA, W sub A, W sub Q over W sub A. So after calculation, so P sub W is equal to 0.04278 or 4.28%. Now to conclude, so based from the analysis, from our previous analysis, the following can be concluded. So first, the process that is being implemented in the process of billing in the Nagat Islands District Engineering Office is about 90% effective as presented through the multiple server exponential service time queuing model. Second, the process chosen to process the billing may have a 10% chance that it will be idle, meaning there is a 10% probability that it would be it would not be working. Then next conclusion, in every batch billing, an average of 8 vouchers can be accommodated simultaneously. Next conclusion, so there is a 10% probability that there will be no voucher to be processed in every month. On the contrary, there is a 90% probability that the vouchers will be processed in every month. Next conclusion. Upon submission of request for billing, the voucher could take an average of 7 days for it to be pending along the line. And our last conclusion is, but it would not mean that it would wait too long to be processed, since there is a 4.28% probability that it will wait to proceed. In other words, there is a 95.72% probability that the voucher will be processed in less than or equal to 7 days. That's all. Thank you.